name's John, and this is my report for the animatronic face project for SEE215 Microcontroller Principles, trimester 2, 2015. The basic guidelines for the mask were that it needed to have two independently moving eyes in the horizontal plane, two eyebrows which were also independently controllable, and a mouth which could open and close. Obviously I've gone for something a little bit different, a little bit more complicated than that. I was after something that looked a bit more realistic and had a bit more of a three-dimensional look to it. So I ended up going with eyes that could move horizontally and vertically independently. The eyebrows can raise and lower, they're basically just a rotation. And a mouth which has 4 degrees of freedom, they can move the corners up and down and the centres of both lips up and down independently. So before we go any further, I'll give you an idea of what it can do.
For the code to run the mask, I chose to use arrays which would hold the facial expressions ready to be passed into a make expression function from the main program. Each expression is a series of 10 digits which represent different positions for each of the 10 servos. After defining those expressions, we set up the pins for the keypad, the servos, set up the timers for fast PWM, and load the neutral expressions into each of the servos. In the main program loop, each column pin is cycled low for a short period of time. When a key is pressed on the keypad, the corresponding row pin is made low, which triggers the interrupt handler for that pin. For instance, if the 8 key is pressed, the interrupt handler for int2 is thrown into action. The interrupt handler runs a series of if statements to determine which pin is low, representing which row is low on the keypad. So in our instance, if row 2 pin is low for keypad 8, then we will return the value 8 through the button pressed variable to the main loop. At which point a switch statement is executed, and depending on which button presses come back through the interrupt handler, the make expression function will be called with one of the arrays defined earlier. In most cases it's a simple single call to the make expression function, but in case 8, which I like to think of as a bit of a demo reel and shows off a number of different facial expressions as you saw before, it calls a series of 10 different facial expressions with a slight pause in between each one. The make expression function takes one of the expression arrays as its input and runs through a series of processes to make a nice smooth transition from one facial expression to the other. Determines the maximum difference for any one facial feature moving from the old position to the new position, and then cycles through each servo in turn and runs a little switch case option to make sure we move in the right direction for each option. The small delay at the end here to slow the motion of the servos down has worked quite well to make the mask move smoother. If you run this delay a little bit too high, then in the end the motion becomes quite jerky. The final function is the delay for function, which just handles all the delays for the program.
So now let's have a quick look at the keypad and the internals. The keypad is 2 layers of aluminium strips. The top layer is the rows, the bottom layer holds the columns, and they're held apart by folded sections of cardstock. Just provide a spring action to make sure they're not in contact all the time. Masking tape holds it together. Underneath the box we have all the internals, all the electronics. Firstly, the column pins as they come out of the the Arduino, they are set as output pins in the program, so they are cycled on and off. The row pins head into pins 19, 20 and 21 of the int0 to int2 interrupt handlers. Got our 4 AA batteries for power, pin outs to control the servos, come onto the breadboard. The breadboard's there for distributing power to the servos. And of course the 9-volt battery which runs the Arduino. Initially the thought was to mount all that nicely underneath the bottom of the box, but since this doesn't need to be portable, I didn't worry about it. So now let's run through the functioning of the mask based on keypad presses as required by the unit. First one is a neutral expression. There's the second expression. Third, fourth and fifth. As mentioned in the coding section, each one of these expressions is just an array of 10 positions for each servo. So we can program pretty much with anything we like. Things like an evil grin or disappointment that the whole demo is over.
So now let's have a look at some of the internal components. The eyeball was made from 65mm foam ball cut in half, slightly hollowed out to allow for the dowel shaft to fit inside. The dowel is 16mm in diameter. The orange bead in the middle there is 12mm in diameter, and from memory I drilled a 10mm hole down inside the dowel and then hollowed out a spherical shape inside using a Dremel. You can see the nail glued through the bead. That is then inserted into the half of the foam ball to create 2 little eye stalks. You can see the rubber band on the eye stalk here. That just allows it to hold the 2 halves of the dowel together, provide a slight amount of friction there so that the eyeball isn't wobbling around completely unrestrained. Here we see the back of the eyeball. It's a disc of 3mm MDF glued to the polystyrene, along with some cut down servo arms. Each servo came with 3 servo arms, so I had plenty to spare there. The connecting rod is just 1.25mm wire, and it's just run and bent around between one servo and the control horn. Here we see the guide mechanism that I made up to control the eyeball. When I first tested the servos on the eyeball, I found that they would rotate around the central shaft, making the eye uncontrollable. This slot in the piece of MDF controls the horizontal bar for the eyeball and means that it cannot rotate. Here we see the back of the lip mechanism. We've got the control rods with the central lollipop shafts that fit over the 1.25mm wire and allow the movement of the lips up and down at the corners and at the centres. You can still see the necklace string, which is slightly elastic. Inside each of the lips there are 3 sections of lollipop stick which allow it to just form a nice lip-like curve. Here we see the final mouth mechanism, a frame of MDF which supports 1.25mm wire which provides guides for each of the connecting points used. The 2 servos on the outside control the corners of the mouth. One servo at the top controls the centre lip of the top. One servo at the bottom controls the centre of the bottom lip. And this all is then attached in behind the main frame. Here you can see the final eyebrow mechanisms. Here's the guide mechanism that was 3D printed based on the Fitzpatrick work, and the guiding arm where the eyebrow attaches here once it's gone through the mask feature. Servos at the top simply move up and down to control the up and down motion of the eyebrows. Here's a photo test fitting the servos to see if they've got enough clearance around the eyeballs and to make sure that they lined up nicely with the slots in the face. And finally, we've got a photo of the back of the mask to show the frames off. We've got the main box section and the vertical support that we started the whole thing with. In behind there you can see the jaw mechanism subframe, and obviously all the wiring siphons down through a hole at the back of the box to get to all the internals.
Good one, buddy.
Did you see me do?
I did.